Alright, welcome to Experimental Psychology. Um, sa previous lesson, na-explain natin yung single shot design or single end design. Ngayon, alam natin na hindi siya ma-generalize sa lahat kasi nga, few lang yung population o few lang or may specific number lang tayo ng tao na kailangan ma-apply yon para magawa yung isang intervention. Ngayon, let's move to um, experimental designs part 2. Alright? So, this is true experimental designs. We already explained that one sa previous lesson natin. Okay? So, topic 1, true experimental research design. Alright? So, through experimental design, experimental research is quantitative approach researchers use to discover cause and effect relationship. Ibig sabihin, gusto natin makita kung pag tayo nagpasok ng treatment, may effect ba to or may relationship ba to doon sa gusto nating makita. Okay? So, thus, some variables are deliberately manipulated or varied to observe how this will affect other variables. Example neto is a researcher may prescribe different diets, low carbohydrates or no carbohydrates at all, to individuals who are obese to observe and how this will affect their weight. Okay, so through experimental design, ay yung nagkakandak tayo ng experiment or intervention para makita natin kung may pagbabago ba ito doon sa variable natin or sa gusto nating makita. According to Mill 1874, he identified 3 basic criteria that a researcher must meet in order to establish a cause and effect relationship. Number 1, the cause of precede the effect. Okay? So, may epekto ba ito yung nilagay natin or yung naglagay tayo ng treatment? The cause must be related to the effect. Okay? So, dapat gusto natin makita kung yung pinasok natin na independent variable or isang treatment ay may epekto sa dependent variable. No other explanation must be offered for the effect observed except for the cause investigated. This is the advantages of experimental method. The experimenter precisely manipulates one or more variables of his choice. Okay? So, number 2, the independent variables are controlled, thus, internal validity is obtained. Kasi nga, in experimental psychology, in experimental design, tinitingnan natin na kung may pagbabago ba pag tayo nagpasok ng treatment. That is why kinokontrol natin siya and minamanipulate. Number 3, they have produces results that have lasted over time and suggested new studies and solutions to practical problems. Okay? Kaya susubukan natin i-generalize yung result neto para makita kung applicable din ba ito sa iba kapag kinandak to. Okay? So, it is economical and convenient situation can easily be created in a laboratory. Okay? However, meron ng disadvantage. Disadvantage for this one is, number 1, laboratory findings are obtained in artificial and sterile atmosphere that prevents generalization to a real-life situation. Number 2, experiments may be extremely time-consuming. Bakit? Time-consuming in a sense na hindi lang ito basta-basta na magpapasok tayo ng treatment at iiwan na natin yung participants like yung ginagawa sa single shot design. Designing the experiment and conducting it can take up a lot of time. Kasi nga, meron tayong series of intervention or series of treatment na ibinibigay dito. Alright. So, research setting. Bago tayo pumunta sa different experimental research design, punta muna tayo dito sa research setting. Saan ba natin siya pwedeng i-conduct? The two research setting open for psychosocial research are the laboratory and field setting. Experimental approach is used in both laboratory setting and the field setting. So, pwede to sa laboratory and pwede din to sa field setting. Depende sa kung anong type of participants na gagawin natin. Where the field experiment is strong, the laboratory experiment is weak and vice versa. Bakit? Kasi kung doon tayo sa laboratory experiment magkakanda, ay iba ang atmosphere neto at hindi natin alam kung ma-generalize ba natin kapag inilabas natin itong experiment na to sa field or kung applicable siya. Same with in a field and also sa field kasi mas madami compare dun sa laboratory ng participants mo ay maaring minimal lang. In laboratory experiment, a laboratory is any research setting that is artificial, relative to the setting in which the behavior naturally occur. Okay? So, example nito ay kay Pablo, classical conditioning, yung Banduras-Bobodal experiment. Ito ay kinandak doon sa laboratory. It can be formal laboratory but can also be a classroom, a room in the library, or in any building set up with necessary apparatus. Alright? So, laboratory experiment. A study conducted in laboratory where the researcher precisely manipulates one or more variables and control the influence of nearly all the extraneous variable. Okay? In laboratory experiment also, the independent variable is manipulated within the carefully controlled confines of laboratory. Outside influence such as presence of others, noise, or etc. can be eliminated sa laboratory. Kasi nga, meron tayong specific na setting ng pagkakandakan. And pwede natin ma-normalize yung mga extraneous variable. Laboratory experiments yield the greatest control since participants are tested under controlled environments. Note that not all extraneous variables can be controlled. Bakit? Halimbawa, bago mo i-conduct yung experiment kay client or bago siya pumunta doon sa laboratory na yun, may extraneous variable na nangyari. Halimbawa, time of sleep, and also halimbawa is the attitude. Okay? So, hindi lahat ng extraneous variable ay makokontrol mo sa laboratory. Ang advantage nito ay experiments are the only means by which cause and effect can be established. They allow to precise control of extraneous variables, which allows a cause and effect relationship to be established. Laboratory experiment can easily be replicated because a standardized procedure is used. Okay, so in laboratory experiments can easily be replicated because a standard procedure is used. Alright, kasi nga, meron tayong specific na setting. And madali lang i-replicate yung ginawa nating intervention sa mga susunod na procedure. Or if we want to replicate that sa other participants. Disadvantage neto ay artificiality. Experiments conducted in the laboratory are not typical of real-life situation. Example is low ecological validity. Demand characteristic can be or can confound laboratory experiments. Cues in the environment of which participant guessed the purpose of an experiment. It is not possible to control the extraneous variable. Okay? Hindi na lahat ng extraneous variable ay may kukontrol natin sa laboratory experiment. Now, let's move to field experiment. With this field experiment, an experimental research study conducted in real-life setting in the participants' natural environment. The researcher decides which variables to manipulate, how to manipulate them, and when to manipulate them. It has all the qualities of the laboratory experiment except that the research is conducted in real world. Also, there is less control than one would have in laboratory experiment. Advantage ng field experiment is less artificial than the laboratory. Field experiment is more likely to reflect a real life because of its natural setting. There is less likelihood of demand characteristic affecting the result. This occurs when the study is covert. Laboratory experiments can easily be replicated because a standardized procedure is used. Okay? And now, it has a disadvantage. There is a less control over extraneous variables that might bias the results. Okay, so, kasi nga, nasa field to, and then, hindi equal yung places na meron tayo sa laboratory than to field experiment. Halimbawa, kung sa field experiment, mas maraming extraneous variable dito kaysa sa laboratory experiment. Okay, such as noise, hindi mo makokontrol yung mga ganon. This makes difficult for another researcher to replicate this study in exactly the same way. Okay? It can be the same procedure, however, the same way na kung saan makakonduct mo yung experiment dahil nga sa field to ay mahirap i-replicate. Now, we have true experiment, a study in which a researcher actively manipulates a variable that participants are exposed to. Okay? So the researcher can randomly assign the independent variable to the groups of participants involved in the experiment. Okay? In true experiment, papasok dito yung randomly assigned ng independent variable natin. Okay? Extraneous variable are controlled, while the influence of independent variable is tested. Best demonstrate a cause-effect relationship among variables. Yung internal validity established because validity established because cause and effect relationship can be established. The experimenter has complete control over the experiment. Okay? The who, the what, when, where, and how to conduct the experiment. A true experiment with a true independent variable allows random assignment of subjects to each conditions. So, meaning to say, si experimenter ang magde-decide kung kanino niya i-randomly assign yung mga independent variable. Often thought of as a laboratory study, but this is not always the case. Okay? True experiment can also be conducted in the field. Now, we have types of true experiment. The basic element necessary in true experiment. It should answer the research questions. Adequately test the hypothesis. Control in experimentation. Control extraneous variable or randomization. A control group as a standard of comparison. And generalizability. Applying findings to individual other than those tested. In true experiment design, kasama dito ang pre-test post-test design, post-test only design between and within the subject. Now, let's move to this type of true experiment, which is number 1, the pre-test post-test. Randomly assign participants to the groups. Okay? So, meron kang control group at saka meron kang experimental group. First, measure the dependent variable or pretest in both groups. I-measure mo yung pretest ng control group at saka experimental group. Tapos, i-administer mo yung experiment mo doon kay or kukunin mo si independent variable or yung intervention mo. Okay? Tapos, ilalagay mo siya sa experimental group. Tapos, titingnan mo ang dependent variable again. Okay, kukunin mo yung post-test ng dalawang group. Tapos, compare mo kung nagbago ba or nagkaroon ba ng effect yung experiment mo doon sa experimental group. So, this is an example diagram of pre-test post-test design na nire-require. Okay? So, meron tayong pre-test. So, si pre-test ng control at saka kay experimental, same sila. Ngayon, ikakandak mo itong si experimental treatment. Okay, and then magagawa ka ng post-test. Pero, si control group, since na-control siya, hindi ka maglalagay ng kahit na ano. Pero, ipopost-test mo siya. Tapos, i-compare mo kung nagbago ba ang post-test netong dalawa na to. Kapag nagbago ang post-test netong dalawang to, maaaring, kahit wala ka nilalagay na treatment, maaaring kahit no treatment ka, or hindi ka magkaroon ng treatment dun sa control group, okay, maaaring nagkaroon doon ng extraneous variable or napasukan siya, kaya siya tumaas, or kaya nag-iba ang post-test niya. Or meaning, hindi, kahit na wala kang treatment, pwedeng mabago yung pre-test at saka post-test ni control group. Okay? So, bakit maganda gamitin sa pre-test and post-test? Maganda to gamitin kasi nako-compare mo, meron tayong control group at nako-compare mo kung may pagbabago ba or may effect ba ang intervention mo or ang treatment mo kasi nako-compare mo yung post-test nilang dalawa. Okay? Extraneous variable history and maturation variables are controlled. Any difference produced in experimental group will also be produced in the control group. Now we have post-test only design. The independent variable is administered to only the experimental group. Then the dependent variable is measured in both the experimental and control groups. Post-test scores of the two groups are compared to assess the influence of the independent variable. So, this is an example diagram of post-test only design. So, kung makikita, wala tayong pre-test na in-administer. Tapos, dito, sa experimental group, nagpasok tayo ng treatment and then kinuha natin yung post-test. Kay control group, wala tayong nilagay, nag-randomly assign lang tayo, pero kumuha tayo ng post-test without any treatment. This format represents only the basic structure of post-test only design, as I mentioned. The exact structure of final post-test only depends on the several factors. These factors determine different types of post-test only design. Okay? So, we have within the subject and between the subjects. Example neto is yung beer. Kumuha tayo ng participants at ni-randomly assign natin siya. Kaya within the halimbawa, example sa between the subject designs muna tayo. Sa between the subject designs, ito yung also called as between the groups. Okay? So, titingnan natin yung post-test neto ni control group at saka na experimental group after ng treatment na experimental group. Sa within the subject, halimbawa, okay, example natin si beer. Meron tayong control at saka meron tayong experimental. Sa experimental group, pinainom natin yung participant ng beer. Kay control group, maaaring pinainom natin sila ng tubig or pwedeng wala tayong painumin, and then itetest natin yung memory retention nila after nila maganda or after nila makainom ng beer. Okay? That is the between the subject or between the group. Kaya within the subject, halimbawa, itong si experimental group, yung isang participants natin kay experimental group, kaya siya tinawag na within the subject, ano ang level ng memory niya kapag pinainom natin siya ng isang bote, okay, Sa second participant natin kay experimental group, pinainom natin siya ng 2 bote. Kay third participants natin na experimental group ay 3 bote. Sunod, 4 na bote. Sa isang participants, 5 bote. Okay? Tapos, kakonduct tayo ng post-test kung ano yung nagbago doon sa within the subject. Okay? Kung may pababago ba sa ang taong nakainom ng or ang participants na nakainom ng 1 bote, 2 bote, 3 hanggang 5 bote. Tapos kukunin natin yung post-test nila at i-compare natin yung kay control group. Pero syempre, kay control group, wala tayong ibinibigay or administer na kahit na ano. Ang advantage nito ay different group of participants are tested, thus sequencing effect does not occur. Also, participants are randomly assigned to the various groups so that the groups are equated. Thus, participant variables that may interfere with the effect of the independent variables are controlled. Okay? Now, we have Solomon 4 design. Kay Solomon 4 design, simple and robust design, uses pretest and post-test. Usually uses or used to assess treatment in teaching effect. Okay? Randomized participant to 4 groups. Kay Solomon 4 design, meron tayong 4 na grupo or 4 na grupo. These are symbolizes the randomized respondents natin na per group. Okay? Yung dalawa dito, analysis 1 is compare natin yung group 1 and group 2. This is the group 1, this is the group 2. Assess natin yung treatment effect na may treatment or may intervention, tapos kukuha tayo ng post-test. Tapos titingnan natin kung may difference yung walang intervention dun kay group 1 at kay group 2 sa may intervention or sa may treatment. Analysis 2, compare natin of groups with and without pretest can assess 4. Okay? Okay, halimbawa, wala tayong pretest, wala tayong post-test. Tapos, i-compare natin yung isa, lalagyan natin ng treatment, tapos maglalagay tayo ng post-test. Okay? So, student pretest, you are biasing the results of the study. This is rather intuitive. Most of us, we give our student a pretest. It's giving a hint of what post-test is likely look at. Okay? So, sabi natin kanina, si Solomon 4 group design, kinakonduct to minsan ng mga teacher or best siya. Kaso, dito, maglalagay tayo sa kanina, kung naglagay tayo ng pretest, post-test, titingnan naman natin yung sa Solomon 4 design na wala siyang pretest. Bakit? Kasi gusto natin makita kung may nagbago ba kapag nagpasok tayo ng teaching strategy. Minsan kasi, kapag nagbibigay tayo ng post-test, nagkakaroon na ng hint yung mga bata or yung mga students kung ano ang mangyayari sa post-test nila or kapag or hint kapag nag-conduct sila ng post-test exam. Analysis 3 uses a meta-analytic analysis in order to add the effect of the pretest and non-pretest group. In effect, we all combine all 4 groups into a single outcome measure. So, i-combine natin ngayon itong pretest and post-test na may treatment, tapos i-combine natin ngayon yung walang pretest na may treatment, tsaka post-test lang. So, combine natin itong dalawa, okay? I mean, compare natin itong dalawa, and then compare natin itong dalawa, and yung result nito is ko-compare natin sa bawat isa. Yun si Solomon 4 group design. Okay? Si 1 and 2, ko-compare natin na may pretest, tapos yung isa sa kanila may treatment, tapos kukunin natin ang post-test. Kay group 3 and 4, randomly assigned siya, wala siyang pretest, pero yung kay group 3, meron tayong treatment, at saka tayo magpo-post-test. However, kay group 4, wala tayong pretest, wala din tayong treatment, post-test lang. Tapos, magkakonduct tayo ng meta-analysis if may pagbabago dito may pagbabago dito sa 4 na grupo. Ang advantage nito increases internal validity, simple to implement, easy to document methodology, assess for pretest and sensitization. Ang disadvantage nga lang niya, requires large samples kasi nga, mas maraming grupo ang kailangan natin. Statistically, analysis is complicated kasi nga, gagamit tayo ng meta-analysis at saka, titingnan natin, kung sa meta-analysis kasi, malalaman natin yung sa inferential statistics when we discuss the meta-analysis part. Okay? So, malalaman natin kung ano yung flow ng group 1, group 2, group 3, paano makuha yung differences nila or makukuha yung comparison nila. We also have factorial design. Kay factorial design, 2 or more independent variables are investigated. Investigated simultaneously. Variables are also known as factor. So, right? In this scheme, the x and y are the factors of independent variables. The entire design is combination of the vectors. Factorial, and this design also called 2x2 design because each vector has 2 levels. Okay? Halimbawa, investigating if a new drug reduces migraine attack, we could create 3 conditions. Okay? That differ the dosage of the drug. Halimbawa, nagpasok ka ng drug, gusto mo makita if that drug is effective. Okay? The diagram shows if the high dosage of the drug can decrease the migraine. Okay? So, meron tayong low, medium, high. Okay? The line in the graph represents the dosage and being connected to visualize the dosage of the drug and to see if the average migraine attacks increases or decreases or stays the same across conditions. The example is a simple factor but can be extended in adding another factor. Example, gender. If you add 2 or more factor, we refer that as factorial design. Okay, so gusto kasi natin makita kung if magpasok tayo ng drug, is tataas ba siya or bababa ba siya? Okay? However, pwede din natin magpasok ng gender dito sa factorial design. Kung gusto natin malaman kung ang drug ba na in-administer natin ay mas mabilis na makapagpawala ng migraine ng participants kung siya ay babae or siya ay lalaki. Okay? With the example, we could investigate which dosage is good for decreasing the migraine attack, and with that, we can investigate the effect of the gender. Okay? So, meron tayong halimbawa, ito ay male, ito naman ay female. Pagkatapos, low, medium, and high. Okay? How much ang effect ng tao na ang dosage niya, how much migraine experiencing ng participants. Kung ang dosage niya ay naglagay tayo halimbawa 500 mg, both to 500. Ito naman ay 1,000, ito naman ay 1,500 mg. Sa factorial design, tinitingnan natin yung effect ng bawat dosage. Also, pwede din natin tingnan kung saan mas mabilis gumana ang effect na per dosage, sa babae ba or sa lalaki. Okay? So, hindi lang siya basta the effect of dosage, nilalagyan din natin ng level or number of dosage. Tapos, tsaka natin kino-compare yung bawat dosage doon sa gender. So, maraming factors tayong tinitingnan kay factorial design. Not only kung effective ba yung gamot na yun, but also kung effective ba yung per dosage at kung nakaka-apekto ba to sa gender ng participants. Or may apekto ba to kung male or female ang gender ng participants. We can also investigate the combined effect of the two vectors. We can see if the higher dosage of a drug is more effective in reducing the number of migraine attacks for women as compared to men, as what I'm saying earlier. The effect of the fixer separately are referred to as many effect. The combined effect of the vector is called the interaction effect. Okay? So, this is the interaction effect. Okay? Ng male and female within the dosage. Titingnan mo kung itong level ng drug, ang sabi natin kanina, ito ay 500, ito ay 1,000. Kung sa 1,000 milligram na binigay mo ay may interaction effect sila, or nag-crossing line nila while you are conducting the experiment, or ina-analyze mo na yung data, that is the interaction effect. Dito sila sa point na to, sa medium, na nag-interact. Meaning to say, kung kanina, sa low, kapag ito lang yung milligrams natin, ay walang interaction effect, ibig sabihin, ay maaring pwede lang siya kay male or maaring pwede lang siya kay female. Ka-interaction effect, tinitingnan natin kung saan sila magko-cross yung point. Okay? So, that is the factorial design. So, hindi lang isa ang tinitingnan natin, kundi madami. Okay? Madaming factor. It can be number of dosage, it can also be gender. And then, doon tayo makapag-conclude kung saan doon yung interaction effect. Saan sila magko-cross ng line. Okay? So, for the next experimental design, we will discuss it later sa next video natin. Okay? Thank you for listening again and hope you are learning.